The Bacillus thuringiensis, or Bt gene, is a common soil bacterium around the world. The Bt bacteria and proteins have been used for several years as biological controls for certain insect pests in farming, particularly the organic food sector.
Well, Bacillus thuringiensis is a bacterium which has many beneficiary genes in them. Many of these genes are used, to produce certain proteins, the cryo, genes. Proteins which are kind of poisonous to many insects, and they help in protecting our plants against pest infestation. It is like a mystery, when you look at the Bacillus thuringiensis, in the sense that there are pluralities of genes in it, so that one protein may be harmful to a particular insect, but not to others. So there is selectivity in terms of that, such that there is the target insect and the non-target ones.
Bt is a bacteria living in the soil. It is called, in our jargon, scientific jargon, Bacillus thuringiensis. So this is where the B and T came from, Bacillus thuringiensis. If you go to any shop where pesticides are sold, you can find the bacterial spores, live bacteria is sold as a biopesticide. You can go and apply it in your crops if you got some worms which penetrate into the fruit or the stems. The bacteria itself is sold as a biopesticide since 1930s.
Some approved crops fortified with the Bt gene around the world include the Bt maize and the Bt cotton, which have been used and consumed in some developed nations and even South Africa.
The technology used for Bt COWPEA is the same as the technology used for Bt maize that you mentioned is already being grown and consumed in South Africa, also being grown and consumed in many countries around the world in large quantities in that. And we have more than 2.5 decades of experience with crops such as Bt maize. So the same technology in Bt COWPEA, it's been tested, it's shown to be safe. We also have the same technology in eggplant, Bt eggplant, which is being grown by farmers in Bangladesh and consumed. So there's a lot of experience with the technology and every reason to believe, of course, the product is safe. So there are no concerns.
The Bt gene has now been infused into the COWPEA plant to fight the Maruca pod borer, an insect pest that preys upon COWPEA plants in many African countries, including Nigeria. This follows previous research by scientists to stop Maruca infestation on COWPEA plants, which were unsuccessful.
Some work by IITA in the late 90s and early 2000s, trying to get some conventional COWPEA varieties from wild sources, which they cross to ensure that those varieties are having some level of resistance. But those varieties have not been successful. They could not protect the crop against the pod borer. So they are not successful with farmers because they don't have a good seed color and seed size, and the resistance is not durable. It has broken down. So we have to restore to this Bt using biotechnology to integrate some genes from non-related plant species. Because bacterium is a plant, COWPEA is a plant, but we took this bacterium from this gene from bacteria to our crop COWPEA. This is why it is very novel. It's a new work.
The Bt gene-enriched cowpea is also known as the Maruca-resistant cowpea and contains the CRY1AB and NPTLL genes.
A Bt gene is a gene that enables an organism to protect itself against some group of insects. They are called lepidopteran insects. These are chewing insects and is restricted to only those ones. So any plant that has this gene in it will be able to protect itself against this invasion of these insects as if it has been sprayed with an insecticide. And the origin of this gene came from olden days when farmers discovered that by fermenting soil they will be able and decant the water from that fermentation process, and they spray it against their vegetable crops. The vegetable crops are effectively protected against insects that come and feed and destroy them. So scientists from that observed and discovered that there's a particular ingredient that allows or permits insecticidal effect which comes from the soil.
The Bacillus thuringiensis bacteria produces specialized proteins, also known as the Bt protein, which kills certain types of insects without affecting living organisms. This means it is safe for human and animal consumption. It has been extensively studied with regards to crop safety, with no concern so far identified.
It has been traced to a particular soil-borne organism, a bacteria, freely found. This bacteria is harmless. It does not do any harm to human beings. Neither does the gene also does anything to human being except for these insects. From that, then scientists found a way of getting this, isolating the gene and then incorporating it or improving the performance of different plant materials. One of them is maize. It has been used in cotton, is used in garden egg, and we are now taking thought in Nigeria to use it in cowpeas or beans, as we call it in Nigeria.
Yeah. The science is that the gene produces a protein which is harmful to the maruca, but is not harmful to the human. What it does is the caterpillar is the ferocious, form, the stage of the insect, and what it does is, as it bites on the chew, either the leaf or any component of the plant, then this protein that we are talking of will now affect, the gut of that caterpillar and therefore kills it. The physiology of the caterpillar is different from that of the human. And the protein that is produced there, I believe, can maybe digestible to the human, while the caterpillar of the maruca may not be able to digest it. Just like we say that one man's honey is another man's poison.
The Maruca-resistant cowpea has also been evaluated from an environmental safety perspective, including its potential to cause harm to pollinators, including honeybees.
Here in Kano, we have been planting for the past 5 years. And I'm telling you, you can even see the soil. You plant the cowpea, you will get the cowpea. And then nothing happened to us who are managing the place. So I don't think if there is any harm to the experiment, planting the GM. It has not changed because it's still producing the cowpea. And we are the people who are working, we are still working, we are not dead. We touch it, we handle it, we do everything. And it doesn't affect us.
In parts of northern Nigeria where beans farming thrives, these farmers sit around in groups worried about huge losses incurred from the infestation of the maruca on their farms.
The pest has really caused us sorrow because we harvest very low yields from our beans farms.
Scientists say the concern of these farmers will soon become non-existent with the approval for the commercial release of the BT cowpea, which has undergone several confined field trials in Nigeria.
Farmers will have to spray less. And when farmers spray less, it means production of cowpea will be economical, because spraying is money. You pay for the herbicides, chemicals, you pay for the labor in spraying. So if instead of spraying 6 times in the crop cycle of cowpea, you now spray only 2 times, that means a lot of savings to the farmer. And it also means that the income of the farmer will be increased. So the impression generally is, one, the release of this variety is likely to improve food security, because it will mean more farmers will be engaged in cowpea production, and it will mean increasing the production of cowpea for the benefit of the nation. And then secondly, it will improve the income of farm household. Farmers who grow this, who are likely to grow these varieties, are definitely going to have more income, resulting from less cost of production and increased yield. And this will be more profitable to the farmers, and many of them will laugh actually to their banks.
The Maruca-resistant cowpea variety is being developed specifically for African farming communities where the Maruca pest challenge is rife. Farmers who have been educated on this variety by the Open Forum on Agricultural Biotechnology (OFAB) and have also been privy to it through confined field trials testify.
If we can get the BT cowpea variety, we will harvest 5 times more yields, because the Maruca does not affect the variety. The BT cowpea only needs 1 or 2 sprays to take care of other insects, and the harvest is huge. The conventional cowpea takes 4 to 5 months before bringing forth yields, but the BT cowpea is ready for harvest in 2 to 3 months. These BT cowpea seeds on my hands are very large and looks better than the conventional seeds we are used to. Maruca and other insects attack the conventional cowpea variety, which I plant, and the seeds come out smaller and fewer. If I can get access to the BT cowpea seeds, I will have a bumper harvest.
The adoption of the BT cowpea variety in countries like Nigeria is expected to improve nutrition and food security for not less than 8 million farmers and their families. This is in addition to enjoying better health, a better environment, and improved outcomes. The BT cowpea will impact on the gross domestic product of benefiting agricultural economies even more than the conventional varieties.
What it can do is really boost productivity for smallholders and also boost incomes for smallholders, because a lot of smallholder farmers now growing cowpea are spending large amounts of money, resources on spraying to control the pod borer. An introduction of pod borer resistant cowpea will reduce those costs. But I do know that from experiments that have been done and studies that have been done in field trials, that when you have the Maruca infestation, your yields can be reduced by up to 90%, 80 to 90%. And this is going to be alleviated by growing the pod borer resistant cowpea. So under the same conditions, farmers might expect to see yields maybe 5 times greater or more, because they have better control of the pod borer.
You have BT cowpea on a good background and you don't spray, your yield can go to 1 ton. That in itself is money for the farmers, is food for me and you. So it will contribute seriously to significantly to the economy. And remember, once it's released, this is at no extra cost. So we look at that bank. So I will expect that the seed of the variety that has BT will be maybe 5% or 10% higher than those ones for a few years. But after that, it will be the same kind of cost. So it will be no extra cost. So the returns on that investment is significant, positive.
The testing phase for the BT cowpea in Nigeria is near completion. Safety testing is now to be completed, after which the crop will be approved for commercialization. A seed production system is to be put in place to give farmers access to certified seeds.